Good morning, guys. How are you? Today we will study the lesson 1 of Unit 2, which talk about the periodic table and how it how this the periodic table can help us to predict many properties of many elements and how to how we can determine the location of any element in this periodic table by knowing some properties or some information about its atomic number. As we mentioned before, the periodic table is an arrangement of elements in ascending order according to their atomic number and the electronic configuration in the energy sublevels according to building up principle. As we see now, the periodic table consists of 7 horizontal rows, which is called period, and 18 vertical columns, which is called groups. Each horizontal row or each period represents one principal energy level. So the first row for principal energy level number 1 or n equal 1, the second period for n equal 2, third period for n equal 3, and so on. Okay, there are 7 periods in the in the periodic table. Each period starts with the filling of new principal energy level. The first periodic table, the first period consists of or contains 2 elements, hydrogen and helium, because the first energy level or the first principal energy level can occupy by 2 electrons only. The second and third period are contain each one of them contain 8 elements, because the second and third principal energy level can be occupied up to 8 electrons. The fourth and fifth period, each one contain 18 elements, while the sixth and seventh period, each one contain 32 elements. As you see here in the periodic table, it is divided to 4 blocks. The left one, called S block, consists of 2 vertical columns, 1A and 2A, while the right side of the periodic table consists of B block, in which consists of 6 vertical columns. One of them is called group 0, because its elements or the elements which present in group 0 is called inert or noble gases, because they are fulfilled with electrons in all principal energy levels. Though they are inert, cannot participate in the chemical reaction in normal conditions. In the middle of this periodic table, we will find the D block. This D block consists of 4 series. Each series is resulted from successive filling of the sublevel. So each series consists of 10 elements. Finally, the F block is located below the periodic table and consists of 2 series or 2 rows. The first one called lanthanides, the second one called actinides. This series is resulted from the successive filling of F sublevel. F sublevel consists of 7 orbitals. Each orbital can occupy by 2 electrons. So the lanthanide series contain 14 elements, as the actinides series, which also consists of 14 elements. The periodic table contains 118 elements. Only 92 of them are real elements, can be obtained from the earth crust, while the rest are artificial elements prepared or synthesized in the lab by science. And also these artificial elements are radioactive because their nuclei are unstable. How to detect the position or location of any element in the periodic table. We can do it by the knowing or by the information of atomic number, its atomic number. We can make electronic configuration. After that, we can determine its location as we will see now. Welcome back. This is periodic table. Each element from its electronic configuration we can determine its block, its period and its group. Firstly, how to detect its block. If the last electrons in the electronic configuration of this element are ended by S sublevel, so this element located in S block. While if the last electrons in the electronic configuration is located in P sublevel, so this element is located in P block. While if the last electrons are located in D sublevel, so the element will be in the D block. Finally, if the last electrons are located in F sublevel, so this element will be founded in the F block. This is for block. What about the period? When we make an electronic configuration for any element, the highest n value in this electronic configuration, this is value represents the period to which the element is belongs to. Okay, if the highest value for n is 4, so the element will be located in period 4. If the highest number or value of n is 2, so the element will be located in period 2, and so on. What about the groups? Actually, the groups, as we said before, they are 18 groups, vertical columns, but they are divided to two categories. Groups are symboled with capital A and groups symboled with capital B. The groups which take a symbol capital A, these are groups of S and P block, while the groups symboled by capital B, these are the groups of block B, block D. Okay, if the last, according to the number of electrons in the last energy sublevel in the electronic configuration, that represent the number of group. Say sodium, its last electron will be located in S, one electron in S sublevel. So this sodium will be present or located in group 1A, while the chlorine, the final or the last electronic electrons or valency electrons, they are located in S and P sublevel. there are 7 electrons or 7 valence electrons which located are chlorine located in group 7A and so on. While if the element is ended by D sublevel, so the number of group will be determined according to the number of electrons in D sublevel. Here, if this is according to the electronic configuration of D and S sublevel, the last two sublevels of the electronic configuration, the element will be found in its group. If there are only one electron, this will be in 1B, 2 electron in 2B, 3 electron in 3B, and so on. Take care, group 8B, actually they are 3 vertical columns together, which is numbered in this periodic table. 8, 9, and 10 vertical groups, all of them are called 8B. Also, we can write the electronic configuration of any element by the information or notification, or by the knowing of the nearest or the inert gas which precede it. For example, sodium electronic configuration can be written by knowing the electronic configuration of neon and 3s1, while the calcium can be written by knowing the inert noble gas preceded it, which is argon, and 4s2, this is for calcium, and so on. Okay, this is our session for today. Today we will solve some problems to illustrate the idea of this lessons. Now we will take some examples of questions which can solve it now. For example, these graphs. The first graph, which of the following graphical figures represent the relation between number of principal energy level and the atomic number of the elements in the same vertical group? So we can see this in the periodic table, group 1A. This is one group, so it is like one family. They are similar in their properties due to the similarity in the number of valence electrons. 1A, all the members of 1A have 1 electron in valency. In 1A, hydrogen is started with 1 atomic number, lithium with 3 electrons in atomic number, 3 protons in atomic number, sodium 11, potassium 19, and so on. When we move from up to down in the same vertical group or in the same group, the atomic number will increase, also the number of periods will increase. So the answer of this question will be number C, direct proportional relationship. In the second question, we will find also some graphs. In these graphs, we'll determine the relation between a number of valence electrons and the atomic number of the elements in the same group. As we see in 1E, the number of valence electrons not changed by changing the atomic number. All the elements in the same group have the same valency electrons. So the D will be the correct answer. In question number 5, this is figure illustrate the blocks of periodic table. Y for S block, W for P, Z for D block, and X for F block. So the correct answer will be choice A. In question number 3, the properties of the two elements are similar. Similar distance means the two elements located in the same group. If we study the choices in this question, all of these choices are two elements which which follow each other by one atomic number, like A, potassium 19 and calcium 20. The difference is 1 electron. Ga 31 and Ge 32. The difference is 1 electron. In D, cesium 55 and barium 56. Also, the difference is 1. This means these pairs are for elements in the same period, not in the same group, because the elements in the same group are different with higher number than 1. So the correct answer will be C. Chlorine and bromine. The difference between them is about 18 elements or 18 electrons. This is correct for two elements in the same group. Now we can finish our session for today. I thank you for your attention. Goodbye.